Okay. So I guess my voice is audible. Oh, good. So you can close the laptop for this case. Why? Because it's complete theory right now. Now, quantum machine learning. It's actually, as I am a machine learning guy, I will say, obviously say that it's very easy and everyone should follow machine learning that this and all. Why? Because I have separate bias towards this guy. Why? Because QML is not so easy. That's the first thing which I said before itself. But once we understand how it exactly works and once we understand the insider theories or how exactly QML works or what are the things which we need and all those things, it is actually very easy to execute. But we will be getting a lot of frustration when the accuracy will not increase. Okay? So that is when you use QML algorithms, what happens is that your accuracy will get stuck in between 47 to 70 maximum. That's it. So that is your accuracy will always be in the range of 47% to 72% maximum. So there is the main case. So there is what will happen whenever you are using QML. But if you do some changes accordingly, it will raise to 87%. Because all the machine learning models which we have built in our organization, that is in my own organization, all of them has an accuracy of 92% to 96%. Why? Because of the some parameter change which we are doing or some of the customized stuff which we are doing. That's why we are going to face a lot of difficulty when you are talking about machine learning models, when you deal especially dealing with quantum machine learning. That's hard. Bringing from this guy to this guy is actually a hard process. Okay, that is with respect to accuracy thinking, the QML is very hard compared to classical ML, but with respect to execution or with respect to theory or with respect to everything is very easy actually. Very straightforward, simply. Now, as we are not going to see anything mathematical that much, I guess it will be very easy to execute. And in tomorrow, which will be the last session, we will be executing some of the real-time applications as well. That is the cancer classification, or we can do the fraud detection thingy, as well as we can do portfolio optimization. All we can do in a single day. Why? Because the coding is very easy. How many of you are machine learning guys here? Okay, nice. So if you are a machine learning guy, actually the coding is very small, simply to put in ML. So in ML the coding will be very small actually. But the content behind it is the one which is large. Not complex, large. Okay? Now the same thing goes for my QML as well. Coding is very easy in QML. Actually it's very easy. You don't need to build circuits here. Okay, maximum you don't need to build circuits. Like if you are lying in a range of 47 to 70% thing, you don't need to build circuits actually. But if you want to go from 72 to 86, there you need to build a circuits. But that's not required at this point of time. Like once after the session is done and once after you are starting to do it on your own, then you will be getting exposed to all these things. But at this point of time, that's not that much. Now, what exactly is quantum machine learning? Very simply to put, before quantum machine learning, let's talk about machine learning. How my machine learning will give a particular answer? How it is actually finding an answer? Right? Oh, okay. So by training experience and everything. Okay, completely okay. So simply to put, by some vector operations, agree? How many people agree this one? So if anyone asks you a question like how ML gives an answer, you simply relate the vector operations which are based on the data which I trained in. They won't ask you another question because they will know that you are a pro player in that point itself. Why? Because when you use this word called vector operation, the meaning goes like this, that you are understanding the underlying theory behind the ML models. So why? Because if we talk about ML, it is nothing but the sequential operations which we are seeing with respect to vectors of data. That's the basically which will happen in the back. So that's why the people who have done the code of linear regression, or the people who did not do the code as well, Let me tell you in a very simple way. What will happen? You will give some inputs. That inputs will be sent in the form of a vector. Okay? That input will be sent to a model or I can say machine. And from this machine, this guy has intelligence. This guy has intelligence. So what will this model do? It will use its intelligence. Okay? So from that it will get its intelligence. It will get its intelligence from previous data. It will get its intelligence from previous data. Like 10,000 rows of data, 500,000 rows of data. Listen, only rows of data గురించి ఇంటెలిజెన్స్ తీసుకుంటుంది ఏది the model. So దానికి అంత ఐడియా ఉంటుంది అన్నమాట మైండ్. After having this much intelligence, what it will do? It will take this input vector, it uses that intelligence and it gives a particular output for that given input. Okay, let us consider all of this. Okay, so this will happen in machine learning. Simply do in a very simple order, in a very abstract, very high level. This is what is happening in machine learning. How many of you are very good at essay writing? Okay, so normally if you are very good at essay writing, the meaning goes like this. Meaning, like for example, if you are going to the like in national level or international level essay writing, what exactly will happen there and there? All the people or all the participants, because whatever the topic is, the topic will come something new. Or even the debaters, the guys who can debate well, the annual debates and something like that, or the Democrats. Every time they will be having a new topic, simply do. Or you can say in an abstract manner, every time they will be having a new topic. It's not the same topic again and again. But still they will be able to answer that very well. And still they will be able to debate that very well. Why? How they can do that? Because of practice. That's the first thing. So whatever, if there's a guy who can write a very good essay, whatever topic I give, he can write very nicely even if you don't have the knowledge of it. Simply like in an overview, right? That kind of stuff will happen. How he is able to do that when he don't have knowledge? Because he will have intelligence on it. He will have intelligence on how to write that text. And when like those kind of people, they read a lot of essays. Even if it's on a completely different topic or off topic, they do read a lot of essays. And the debate guys, they in MUS, they will get trained by seeing a lot of debates. They will listen to a lot of debates. Why do they listen to a lot of debates? Because from that source of data, they will get some intelligence from it. So even though that is not answering my own question, like for example, debate in LN అనుకోండి, నాకు ఇదే టాపిక్ వస్తుందో నాకు తెలియదు, వారు కొత్త టాపిక్ ఇవ్వచ్చు చేయలేదు, but still I will be able to answer that. Why I will be able to answer that very well? Why? Because I will gain the intelligence by listening to all the debates which is happening. Okay? So in the same way ML also works. ML ఏం చేస్తుంది, దానికి కావాల్సిన ఆన్సర్ ఇస్తుందనే కాదు, ఏం ఆన్సర్ ఉన్నప్పుడు అన్నిటినీ కన్సిడర్ చేస్తుందా. It considers all the guys or all its data which it requires to gain some intelligence, and it uses that intelligence to answer some user question. That's the stuff which will happen in the backend of the ML. So that's the reason ఈ డేటా ఉంది చూసారా, ఈ డేటాలో పక్క ఇన్పుట్ ఉండాలనే రూల్ లేదు. There is no rule that this input data should definitely be in the data my model is getting trained with. ఏంటంటే ఇన్పుట్ ఎవరి చేతిలో ఉంది, యూజర్ చేతిలో ఉంది, ఇష్టం వచ్చేది ఇస్తుంది. There are no limitations for the user. Right? User can give whatever input he wants. But still my model works well. Why? Because of its intelligence. Right? So there is a primary concept of ML. For the people who don't know ML, I'm just telling you. So this is a primary and basic concept of ML. Okay? Simply to put, data will be sent to some model. So this process is called as training. So దీన్నే మనం ట్రైనింగ్ ఆఫ్ ది మోడల్ అని అంటాం. సో ట్రైనింగ్ ఆఫ్ ది మోడల్ అంటాం ఈ కాన్సెప్ట్. ఓకే, సో ట్రైనింగ్ ఆఫ్ ది మోడల్ అంటే ఏంటి? ద మోడల్ విల్ బి ట్రైన్డ్ విత్ దట్ డేటా టు గెట్ ద ఇంటెలిజెన్స్ ఫ్రమ్ ఇట్. దట్స్ ఇట్. Okay, so that's my training process. Once my training is done, my model becomes a trained model. So what do you mean by trained model? The model which has enough knowledge on the data. That is my trained model. So the model which has enough knowledge with respect to the data. Okay, that is my trained model. Now I will be having a trained model. Now, any user input will be sent to my trained model. Any user input will be sent to my trained model. And this trained model has some intelligence kada. So by using that intelligence, my trained model will answer the user input and problem. So this is what will happen in machine learning. Okay, so this is the completion of what is happening in machine learning in a very simple high level manner. Okay, now coming to the concepts. This entire thing is a vector based operations. This entire ML are the vector based operations. What do you mean by the vector based operations? Very simply to put, the deal goes like this. Whatever data I am having, I will represent it in the form of vectors. The entire data I will represent it in the form of a vector. Okay? What exactly do you mean by represented in the form of a vector? That is, for example, if I have the rows, like let us consider I have a row. So one form of data is table data. Okay? Now, let us consider I have this table. Like 1, 2, 3, 4, 5, 6, 10, 7, 8. Let us consider this my table. Okay, there is one form of data. One form of data which I will be giving to the model so that the model will be trained on that. So that is one form, is a table form. Now, this table format will be trained and will be predicted and will undergo all the operations in the form like this. There is a two-dimensional array, right? There is a 2D array. Okay, so this particular tabular data will be trained or will be stored or will be represented in this particular form. Okay, so this guy is known as a two-dimensional array, which is nothing but I can say it as a vector form. Or typically this is a matrix format, but the insider operators all will happen in a vector format. That is the matrix kind of operations are. So matrix problem and vector kind of operations are. Okay, so like for example, it may seem like operations being done on the matrix itself. A two-dimensional array operations are for I in and a logical computers and when you are talking about ML. When you talk about core ML, the insider communications all will happen with respect to my vector. Okay, even if I am having this matrix, the insider operations only individual work. Okay, the entire logic will be happening or will be executed with respect to the vectors which I am having in my matrix, having in my matrix. Complete matrix okay type is okay, it will happen in my vector. That's why we will call it as a vector based operations or another. There are the matrix based operations or another, but we won't call that. We will call it as a vector based operation. Why do we call it as a vector based operations? Simply to put, even though I have a matrix of data, even though I have tabular data, that will be calculated in a row wise format only. Okay, monetary matrix table of the calculation is not consistent, but no, internally that is not the logic. If you take any mathematical format of the algorithms like linear regression and logistic and RST, even if mathematical format is make a vector represents ability and matrix represents ability. Like logistic regression. So ఎలా తీసుకున్నాం లాజిస్టిక్ రిగ్రెషన్ ఫార్ములా అంటే simply to put it to go in this way. E format లోనే ఉంటుంది. Okay, so it is represented in this particular form only, that is in this particular form only. E form లోనే represent చేయడానికి అవుతుంది కావాలి. అంతేకాని I cannot represent it in the form of a matrix. IJ form లో represent చేయడానికి. So I will, most of the formulas will not represent their values in the IJ format. They will only represent it in I form. Okay, that's why we will call it as a vector based object. That's my first way. Second way, and just talking about machine learning. Okay? The first way of machine learning is vector based object. The second way of machine learning, sequential operation. So that is, I hope you guys remember that maze solving problem which I told in the second way. Red board mein there is a maze solving. So that comes under an optimization problem. So I want to machine learning also like that. That comes under an optimization problem. And I will talk about optimization as well in some time. Okay, so that's a sequential operation. Parallel computation only now go on. Parallel computation veru, operation veru. Okay. Just keep that one thing in mind. Parallel computation is not equal to parallel operation. Computation is different, operation is different. Okay? Operation is the task which we are executing. Or like you can say the logic we are doing, the step we are doing, that is my operation. Computation is the thing which we are solving. Solving can be done in parallel manner, obviously. అంటే ఒకే రూమ్ లో నేను 10 మందిని పెట్టి ఒక్కొక్కరిలో ఒక్కొక్క సమ్ చేయను. That is my parallel computation. Okay, ఎందుకంటే different problems solve చేస్తున్నా. But నేను అదే పీరియడ్ లో ఒకటి మ్యాథ్స్ ఒకటి ఫిజిక్స్ ఒకటి కెమిస్ట్రీ చదవాలని చెప్పలేను. Okay, because if I am having that particular hour is only physics hour or only quantum hour or only maths hour. Okay, if I have the ability to keep that one kid behave in three forms at the same time. అంటే ఆ అబ్బాయి అదే అవర్లో నేను ఫిజిక్స్ చెయ్యి మ్యాథ్స్ చెయ్యి కెమిస్ట్రీ చెయ్యి అని చెప్పాను అనుకున్నా. దట్ ఈస్ ప్యారలల్ ఆపరేషన్. ఓకే, అండర్స్టాండ్ ద డిఫరెన్స్ బిట్వీన్ ఆపరేషన్ అండ్ కంప్యూటేషన్. ఆపరేషన్ అంటే ఏంటి? ద థింగ్ యు ఆర్ డూయింగ్. కంప్యూటేషన్ ఇస్ వాట్? ద థింగ్ యు ఆర్ సాల్వింగ్. అసలు మీరు చేసేది కంప్యూటేషన్. ద టాస్క్, ద వర్క్ ఇస్ కంప్యూటేషన్. ఆపరేషన్ ఇస్ ద లాజిక్ బిహైండ్ దట్. ఓకే, సో ఇన్ మెషిన్ లెర్నింగ్ you will be having sequential operations. అంటే లాజిక్ ఎప్పుడు ఒకటే ఉంటుంది. ఈవెన్ తో ప్యారలల్ కంప్యూటేషన్ ఉన్నా కూడా లాజిక్ ఒకటే ఉంటుంది మైండ్. లైక్ ఇన్ మెషిన్ లెర్నింగ్ యూ హ్యావ్ ఎ కాన్సెప్ట్ కాల్డ్ యాజ్ బూస్టింగ్. సో బూస్టింగ్ బ్యాగింగ్ కాన్సెప్ట్. బ్యాగింగ్ కాన్సెప్ట్ में you will be having parallel computation. ఓకే, అంటే ఏంటి? మల్టిపుల్ మోడల్స్ అన్ని తనితనిగా లైక్ థర్డ్ పార్టికల్ రన్ అయిపోతూ ఉంటాయి ఒకే ఇటరేషన్ లో. ఓకే, ఇఫ్ యు ఆర్ అవేర్ విత్ ML కంప్లీట్ ప్రాబ్లం. ఇఫ్ యు ఆర్ నాట్ అవేర్ విత్ ML జస్ట్ వాట్ విల్ హ్యాపెన్ అంటే when you are talking about bagging ఒక మోడల్ ఉంటుంది. f of x is a model. ఓకే, ఒక డేటా సెట్ ఉంటుంది. x is my డేటా సెట్. ఏమవుతారంటే ఈ x అనే డేటా సెట్ ఒక n స్ప్లిట్స్ కింద స్ప్లిట్ అవుతుంది. ఓకే, అంటే x1 x2 అప్ సో ఆన్ అప్ టు xn అలా m స్ప్లిట్స్ గా స్ప్లిట్ అవుతుంది. అంటే 100 ఉన్నాయి అనుకోండి, లైక్ 100 రోస్ ఉన్నాయి అనుకుందాం నా డేటా సెట్. 10 గా స్ప్లిట్ చేశాను. I will have 10 splits కదా, where each split is having 10. సో అలా x అనే డేటా సెట్ లో m splits గా స్ప్లిట్ అవుతుంది. I will be having n models as well. So m splits ki m models ఉంటాయి. That is I will be having f1x, f2x and so on up to fmx దాకా ఉంటుంది. Okay, so I will be having m different models for m splits. దాని తర్వాత ఏమవుతుందంటే బ్యాగింగ్. I talked about bagging. ఒక్కొక్క మోడల్ ఒక్కొక్క స్ప్లిట్ కి ట్రైన్ అవుతారు. ఓకే, ఈచ్ మోడల్ విల్ బి ట్రైన్డ్ ఆన్ ఈచ్ స్ప్లిట్. నేను ఇప్పుడు మెషిన్ లెర్నింగ్ ఏమన్నాను? డేటా మోడల్ ట్రైన్డ్ ఇంటెలిజెన్స్ అని అన్నాను చూసారా? బ్యాగింగ్ కాన్సెప్ట్ ఏమవుతుందంటే ఆ డేటా స్ప్లిట్ అయిపోతే ఎన్ని స్ప్లిట్స్ అయినాయో అన్ని మోడల్స్ ఉంటాయి ఆ చేతిలో. ఓకే, అండ్ ఒక్కొక్క స్ప్లిట్ కి ఒక్కొక్క మోడల్ ట్రైన్ అవుతారా. అండ్ దిస్ ఇస్ ఇండిపెండెంట్ నేచర్. ఇది నా దగ్గర ఇండిపెండెంట్ ట్రైనింగ్ జరుగుతుంది. ఓకే, ఇట్ ఈస్ ఆఫ్ ఇండిపెండెంట్ ట్రైనింగ్. సో అందుకోసం ఏమవుతుంది, ఆల్ దీస్ గైస్ will be executed parallel. అంటే ఒకే టైంలోనే నా x1 ట్రైన్ అయిపోతే x2 ట్రైన్ అయిపోతే xn దాకా అన్ని ఒకే టైంలోనే ట్రైన్ అయిపోతాయి. ఓకే, సో దిస్ ఇస్ ప్యారలల్ కంప్యూటేషన్. సో ప్యారలల్ కంప్యూటేషన్ ఇక్కడ జరుగుతుంది, ప్యారలల్ ఎగ్జిక్యూషన్ జరుగుతుంది. ఓకే, సో ప్యారలల్ ఎగ్జిక్యూషన్ or parallel computation is possible by classical era, but operation is not possible. Parallel operation will not be possible when we are talking about classical machine learning. Okay, so that is my one, or that's my second thing what I showed. And third thing, n-dimensional space for kernels. So when you are talking about machine learning, you will be having n-dimensional space, and the coordinate space का होता है, అంటే x y z x y z some z dash అలా చెప్పి మీకు n-dimensional space create అవుతుంది, n-dimensional vector space create అవుతుంది ఎక్కడ machine learning cache. Okay, so okay, how many of you are not into machine learning? Oh my God. Okay. Now so what do you mean by this kernels and stuff? Like if I say it's simple ga. Okay. What do you mean by kernels and stuff? Simply to put, kernels is a very easy concept. It's a very simple concept. Kernel at the end is normally to put some space or some entity in which I can represent my one data in another format. That's it. Encoding another. Like the day before I talked about encoding and encryption and differentiator and I told about encoding is what? Simply displaying the data in some another format. Inco layer nunchi display chestha, inco angle nunchi display chestha, right? Same thing is kernel. Okay, kernel and the real definition of kernel kuda approximately same untadi gaani encodes mathematical terms involve ayi untayi, but normally to put kernel ante enti, like not I am not talking about Linux kernel. Okay, this is the kernel of machine learning. Don't confuse this kernel with that kernel. If you are aware of it, don't confuse this with that. Are different kernel and different kernel. So, what is the simple deal about the kernel? For example, let us consider 2, 3, 4 and data points on it. Okay, e data points ఇలా రిప్రజెంట్ చేయాలి. I want to represent these data points in this form. అంటే ఏంటి? So 2, 3, 4. ఈ డేటాని, this is my initial data. ఇది నా initial data. ఈ డేటాని నేను ఎలా రిప్రజెంట్ చేయాలి? I want to represent it like ఈ ఫార్మాట్ లో రిప్రజెంట్ చేయాలి మొత్తం. ఓకే, సో 2, 3, 4 అనేది పక్క పక్కనే ఉంది, ఇక్కడే ఉంది. ఓకే, దిస్ ఇస్ కంప్లీట్లీ అవుట్. సో ఐ వాంట్ టు రిప్రజెంట్ ద సేమ్ డేటా, బట్ ఇన్ సమ్ హైయర్ ఫార్మ్, 8, 12, 16. I want to represent the same data but in some higher form or but in some another form. ఇంకో ఫార్మ్ లో చేయాలి. higher కంటే lower కూడా like 2, 3, 4 ఉందనుకుందాం. I can go with 1, 3/2 and 2 ఇలా రిప్రజెంట్ చేయాలనుకుంటున్నాను. So I am going with 1, 3/2 1, 3/2. I want to represent like 2, 3, 4 నేను ఇలా రిప్రజెంట్ చేయాలనుకుంటున్నాను, లేదంటే ఇదే 2, 3, 4 నేను ఇలా రిప్రజెంట్ చేయాలనుకుంటున్నాను. So in order to represent one guy in another format, like my existing data ne inko format lo నేను represent చేయాలి. I want to represent my existing data in some another format అనుకుందాం. మనం ట్రాన్స్ఫర్మేషన్ అని అంటాం చూసారా, అదే ట్రాన్స్ఫర్మేషన్ కాన్సెప్ట్ ఇస్ ద కాన్సెప్ట్ ఆఫ్ ది కర్నల్ సింప్లీ. Okay, that is in a first transformation 2 3 4 is being converted into 8 12 16. So your concept ఏంటి, every value is being multiplied with 4. That is the concept here. Right? This guy is called as my kernel. Okay? Simple గా అండర్స్టాండ్ అవ్వాలంటే that transform the value, I can call it as my kernel. Okay? So the guy who is responsible for converting the data into another format, who is responsible for the converted format card. The converted format is not my kernel, but the person or the guy who is responsible, the term who is responsible for converting the data to another format. 2 3 4 8 verse 69. 8 verse 69 encoded data అనొచ్చు. Okay? Who is responsible for creating that encode? That is my kernel. So who is responsible for 4 multiplied by 4? This function is responsible for creating the encoding or creating the transformation. This guy is called as my kernel. Okay? So here my kernel is this one. So this is my kernel function. అందుకే kernel function అని అంటారు ఇప్పుడు. So that's why you might be hearing the term as kernel function అని అంటారు. Kernel function అనే టర్మ్ వస్తుంది కానీ where is my kernel అని ఎవరు అడగరు. Kernel function ఏం యూస్ చేస్తామో అని అడుగుతారు నార్మల్. Okay? So this will be my kernel function for this operation. The guy who is responsible for converting one guy to another or one form to another. So one color you change it. That's my kernel function simply. But so it is scalar value కాబట్టి దీన్ని మనం kernel అనే వర్డ్ యూస్ చేస్తాం. సో లెట్ us transform the value అంటే చాలు. ఈ kernel అనే వర్డ్ ఎప్పుడు యూస్ చేస్తాం అంటే if you are talking about vector based encoding, that is I have a vector called A. I need to change this in some A dash which looks like what I should be doing. Here we will be using the vector, here we will be using the kernel. ఇక్కడ మనం వాడాల్సిన టర్మ్ పేరు kernel. ఓకే, అంటే ఏమవుతుంది మొత్తం మీద సో 1 2 3 సో 1 2 3. So this is my A data. So this is my A data. I will do something through which I can convert this A to this particular. So there is something, or you can visualize it. So there will be some kind of plane or some kind of slab or some kind of anything which is responsible for simply flipping this or by simply changing these data points to these points. Okay? And that guy who is responsible for changing the plane or changing the face or changing the structure so that these initial points can be represented as these points, that is my kernel operation. Okay, that is my kernel function. Okay, something, some entity which is responsible for changing or which is responsible for moving these data points called as 1 2 3 to these data points called as 3 5 and 8. So who is responsible? The guy who is responsible for moving them, that is my kernel. Okay, understood what is my kernel? Simply simple అర్థమైందా kernel అంటే ఏంటో చెప్పండి. Yes or no? Okay, I will give one another example. There will be something called as SVC algorithm when you are dealing with machine learning. Machine learning లో మనకి support vector classifier ఒక ప్రాబ్లం ఉంటుంది. Okay, this comes under a classification problem. Second form is regression. Regression అంటే ఏంటి? నాకు ఆప్షన్ లేదు నేనే కరెక్ట్ వాల్యూ దట్ ఈస్ మై రిక్వెస్ట్ ఫిలప్స్ కి ఎక్స్క్యూజ్ కి ఉన్న టైం జాగ్రత్తగా చెప్పాలి ఓకే రిగ్రెషన్ లో ఏమవుతుంది ఇన్ రిగ్రెషన్ వాట్ విల్ హ్యాపెన్ అంటే ఓకే ఫర్ ఎగ్జాంపుల్ డాష్ ఇస్ ద క్యాపిటల్ సిటీ ఆఫ్ ఇండియా అని అడిగారు అనుకో that is the regression form okay so that is New Delhi is the capital city of India